Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we will present about our lab 2 for subject electrical machine and drive, synchronous motor. So our group consists of 3 members, which is me, Ahmad Nizar bin Lukman, Ahmad Syahrul Iman bin Suhaimi, and Syahir Aiman bin Sha'ari. Okay, so for introduction, a synchronous condenser is a synchronous machine that has no load. Many synchronous condensers linked to the electrical grid are hydrogen cooled and rate between 20 MVAR and 200 MVAR. There is no danger of an explosion in the hydrogen content escape over 70%, which is usually around 91%. Because of their great operational efficiency, reliability, control power factor, and minimal sensitivity to voltage dip. Synchronous condensers are mostly utilized in high power application. So the goals of this lab assessment is to look into the effect of a synchronous motor field voltage variation on the power factor of the supply voltage. Finally, we'll show how to connect a three-phase synchronous motor in a star arrangement. Okay, next. Okay, so this is a calculation that we use to get the result. So for power factor, we will use this formula, which is cos theta equal to power factor is equal to uh, power over apparent power. So for active power, the formula is P equal to S times power factor. So for reactance power, we will use square root S square minus P square. And so for apparent power, we will use the formula is S equal to square root P power of 2 plus Q power of 2. So this is the example of the calculation for synchronous motor 1 and synchronous motor 2. For the excitation voltage is 5 volt. Okay, so next I will pass to the next presenter.
Thank you to Ahmad Iza. Okay, this is the result that we get from lab. For from the left is synchronous motor 1, and the right on the right is synchronous motor 2. Okay, for analysis, based on the graph figure of synchronous motor being studied on SM1 and SM2, it reveals a distinct result as the voltage increase. The SE2662 3M in blue is the SM1, while in the SE2662 5Q in orange is the SM2. This is comprehend the two distinct synchronous machine, each having a result ranging from 0 volt to 95 volt, and the comprehend the conclusion of the result as the voltage rises. Okay, for synchronous motor 1, SM1 in 5 volt has a power value of 12.58 watt, reactive power of 38.73 VAR, and apparent power of 40.72 VA, and the power factor of 0.309, suggesting that the power factor is behind because the reactive power is positive. The synchronous generator is absorbing it from the electrical system. Cause it to be under excited at this point, it gradually rises as the voltage rises, but drop as the voltage exceeds 75 volt, since it has a leading power factor. As a result, the reactive power value is given to machine as negative number. Okay, for synchronous motor 2, the same experiment was run on the SM2 from 0 to 65 volt excitation voltage. When the power factor is positive, it indicates that there is lag. It happened because the generator, which was under excited, absorbed reactive power from the electrical system. From 65 to 95, the voltage has a negative or leading power factor. to the motor is pumping reactive power into the electrical system in this circumstance, indicating that the machine is overexcited. Next, I will pass to Ahmad Sharul Iman.
Okay, thank you, Syahid Aiman. Okay, for the differentiation between SM1 and SM2, understanding the difference between SM1 and SM2 synchronous motors can help you grasp how variations in field excitation voltage impact the power factor. And excited motor is one that has a leading power factor and a negative angle. When the motor operates in lagging power with a positive angle, it is the opposite of being under excited. As a result, if it falls in the middle, it indicates that the power factor is unity. Okay, next. Okay, for the conclusion, the power factor is a critical measure in electrical system as it indicates how efficiently electrical power is converted into useful work. Having a low power factor can result in reduced system capacity, higher energy costs, and increased expenses. Therefore, it is important to increase the power factor in power system design and operation. In summary, the laboratory experiment as report provides valuable insights into the relationship between synchronous motor excitation voltage and power factor. Understanding this relationship enables the enhancement of power system efficiency and optimization of synchronous motor performance. The research also emphasized the potential benefit of using synchronous condenser for voltage regulation on long transmission line to ensure a reliable and consistent power supply. So what we get here are the synchronous motor 1 and synchronous motor 2 is quite similar calculation or and simulation. So that's all from our group. Thank you.